Hi class. In this video we begin the discussion on implicit differentiation in your note packet. And so at the top of the page, right, starts to discuss about implicit differentiation. We have some fill in the blank. Up until this point we've looked at functions y equal f of x, where y is expressed explicitly in terms of x. So an example of a function where y is a function of x expressed explicitly in terms of x is this polynomial. Y equals x cubed plus 4x squared minus 5x plus 6. The variable y is all by itself on the left-hand side, and all of the terms involving x are on the right-hand side. So this is an example of a function where y is a function of x expressed explicitly in terms of x. But not all equations are expressed in this form. Some equations express y implicitly as a function of x. An example of that is y squared times the natural log of y equals x squared plus 7. This is an implicit equation. We cannot solve this equation for y, right? Get y all by itself on the left-hand side and only terms involving x on the right-hand side. So we have to use, we can't differentiate this equation directly using the basic rules of differentiation that we learned for exam 1. We have to use implicit differentiation to find the derivative of this function with respect to x, okay? So dy over dx, right, means the derivative of y with respect to x. And how we find the derivative of an implicit equation like this with respect to x. Step 1, differentiate both sides with respect to x, and then we solve the resulting equation for dy over dx, the derivative of y with respect to x. So before we work some examples, we're going to be using the chain rule for the derivative of y to the n with respect to x. And by the chain rule, this is equal to n times y to the n minus 1 times the derivative of y with respect to x. And before we do any examples, I want to explain to you why that is. So back in when we were studying the basic rules of differentiation, right, we learned the power rule on page 15 of your note packet, okay? The derivative of x to the n with respect to the variable x, right, is equal to n times x to the n minus 1 power, right? You just bring the exponent n down front of the x and subtract 1 from the exponent. Well, if we were to differentiate y to the n with respect to y, we would get a similar result, okay? Derivative of y to the n with respect to y is similarly n times y to the n minus 1 power by the power rule, okay? And the reason for that is up here, right? The variable in the numerator and denominator are both x, and the variable in the numerator and denominator here are both y, right? So we get similar results. But down here is what we're interested in. Derivative of y to the n with respect to x, right? We have a similar result to up here, right? To find derivative of y with respect to n with respect to x, right? We bring the n down front, subtract 1 from the exponent. We have n times y to the n minus 1 like up here. But because these two variables aren't the same, we gotta use the chain rule. And so we got to multiply that by dy over dx. And I'm going to explain to you down here below why this is true, okay? So in this example, right, y is a function of x, right? Remember, y values and function values are the same, right? So y is equal to f of x. And so if we differentiate both sides with respect to x, right? Derivative of y with respect to x is dy over dx, right? Denoted dy over dx. And the derivative f of x with respect to x is denoted f prime of x. So we have derivative dy over dx is equal to f prime of x. Now if I take this equation, this equality, and I raise both sides to the nth power. So I have y to the n is equal to f of x to the n, okay? And so now if I differentiate both sides of that equality with respect to x, I have the derivative, or excuse me, backing up, okay? So I have y to the n is equal to f of x to the n. Well, back on page 24 of your note packet, learning the basic rules of differentiation, we learned how to differentiate f of x to the n power. The derivative of f of x to the n power with respect to x, right, is similar to the power rule. You bring the n down front of the function, subtract 1 from the exponent, like I did here. N times f of x to the n minus 1. But then, because this is a function of x inside the brackets, we got to multiply that by f prime of x. We got to take the derivative of f of x with respect to x, which is f prime of x. And this is from page 24 in your note packet. Okay, this is exam 1 material. Okay. Well, y is equal to f of x. So I replace this f of x with y, and I have the derivative of y to the n with respect to x. On the right hand side, I replace this f of x with y, and f prime of x with dy over dx. And I get the derivative of y to the n with respect to x is equal to n times y to the n minus 1 power times the derivative of y with respect to x, right? So that's the chain rule, okay, from page 24 in your notes.